In this lesson, we're going to talk about the network infrastructure. Now, our networks are developed basically from the need to be able to share information between devices. I have to tell you, I remember the day when networking was, I loaded something on a floppy disk, walked it over to another desk and said, would you look at this? I mean, that's what it was. We didn't even really have dial-up, and I mean, network's been around for a while, don't get me wrong. And the floppy disks, well, they were huge. Anyway, but that's what we said, there's got to be a better way. So in general, these networks are basically links that communicate in either analog or digital signals. They are methods we have for transmitting signals over analog telecommunication links, or at least there are some that we can use, that are using either baseband or broadband. Now, baseband is a term that refers to a single signal being injected on the communications link, whereas broadband is two or more signals on the same link, often at different carrier frequencies. So if you have DSL at home, you know that you're plugging your computer into your telephone line, and that same line is carrying your data at one frequency, and at the other frequencies are the sounds you're able to hear on the phone. And so they're at much different layers. I mean, technically, if you had superhuman hearing, you could hear both. And some people actually claim to, and so they put little filters on to help kind of filter that out so they get a clear voice sound. But that's an example of broadband. Cable's the same way with TV and data. Now, today's networks are part of a large, centrally managed, inter-networked architecture solution using a bunch of high-speed, local, and wide-area computer networks. Some of our architectures might include clustering, which are clustering of different types of functions, doing that in a network segment like your web servers or other application servers. And the purpose of that is to be able to get high availability as well as high speed. As an auditor, we have to understand the information technologies that are associated with the design and the development of the telecommunications infrastructure, such as the LAN or the WAN. Let's talk about the types of networks. The first one is the PAN, the Personal Area Network. Now, if you're wondering, is that something you made up? And is that like your personal space? Well, no, it's different. It's a small area of network. Somewhere between 20 and 40 feet of communications. It's all done wirelessly. And the best example of this is your Bluetooth. Now, if you have a headset and a cell phone and they're not wired together, you know that you can wear the headset and you can walk around the room and just leave the cell phone in one spot. We also know we can have printers connected through Bluetooth. It's a radio frequency of a very short range. The next one is the LAN, or the Local Area Network. Now, it's called local because it's basically the equipment that you own, that you're running, that you facilitate or manage. And generally speaking, it's high-speed connectivity. Now, the definition of high speed is ambiguous. It depends really on what you can afford and what kind of legacy equipment you have. And, today, and we'll talk about Ethernet, but we have some very high-speed Ethernet networks. And if, you asked me 10 years ago what was a high-speed LAN, I'd be talking about a 10 megabit Ethernet. And you asked me 5 years before that, I'd be talking about 10 megabit Ethernet on a coaxial cable. I mean, it continues to change in speed, but it's generally higher speeds than what we got if we left our network and went through a service provider to get to some other location. And that, by the way, would be the wide area network. For the most part, a wide area network is considered at some point when you have left the equipment you own. We sometimes call that CPE, the customer premise equipment, and are using other people's equipments to be able to facilitate the communication channel. But more generally, we say a wide area network is one that is crossing a large geographical area. East Coast to West Coast, or, Boston, New York. It doesn't even have to be a coastal thing. A wide area network just means that you're not in your local area network. You're crossing through somebody else's technology, a service provider, to get to some other part of your local area network. You could say that your WANs were designed to interconnect your local area networks, or your LANs. Now, a metropolitan area network is considered kind of like the wide area network. It's not your equipment, it's a service provider, but they provided high-speed connectivity in a smaller geographical area, generally within a city. And so you got better service, better throughput, a lot of better communications. But I got to tell you that little line is blurring right now, because it was not that many years ago that we saw OSI 768 connectivity from New York to Boston. And by the way, that just blows away whatever your speed is in your local area network, unless you're starting to operate, in the 40 gig, 100 gig Ethernet. It's just incredible speed, and that was a wide area network. All right, it's not all for one company. It's going to be divided amongst a lot of different customers. But what I'm getting at is that high speed definition, again, some ambiguity. But anyway, so metropolitan area, that's what it was. The MANs, we called it. We also have the storage area network. Now, storage area network is interesting. It's usually a part of the local area network, but we could also now make an argument that it's a part of the cloud. But all it is a place where things are stored, right? A large collection of storage devices, drives, those types of things. And it's available by network connectivity. So, I go to save a file on my server. I don't save it on that server's local hard drive. It takes a data path to a location and stores it there. But the server often thinks that drive it saved it on is installed directly. It's kind of cool stuff. And we're seeing all sorts of things out there with the storage area networks. And it's just incredible stuff that's happening. Now, there are many services you'll find on the network. One is the Network File System, NFS. Now, let's be fair. I've been saying Windows. That's more of a Unix, Linux file system. But what it is an availability of a server, a Unix-based or a Linux-based server, of allowing remote access connections to be able to retrieve or save files on that server. It's a communication protocol. We have email services, and I'm going to guess that if you're watching this, you've used email before, so you know what that's all about. Print services, roughly the same thing. I send a print job, not to a printer that's on my connected to my computer, but one that's connected to a server that can verify if I'm allowed to do that. Remote access servers are just that, ways for me to connect to a network from someplace that's not in that network. Usually if I'm at home and I need to dial in, it tells you how long it's been since I've been doing this. We used to always call it dial in. If I need to VPN into work, I'm going to connect into a remote access server that's going to negotiate that secure connection, and if it's successful, then it's going to look as though I was actually at that site rather than at home. Directory services, that's your Novell's directory services. They used to call eDirectory and Microsoft's Active Directory. It's basically, the ability for me to have a central login, hopefully even a single sign-on type of setup. All sorts of network management types of services that are out there. Inside of network management, you might have the Dynamic Host Configuration Protocol, DHCP, and the job of DHCP is to assign IP addresses that are used so you can have network communications. The Domain Name Service, or DNS, is out there to be able to resolve the names of a computer or the name of a website into an IP address. You don't have to remember numbers. You can remember names. Lots of different services that are available for us. Now, out of everything I talked about, the reason that it works is that our network architecture is built on standards. And those standards allow the process of creating an integrated environment that applications can work within by having a reference model that can be used for the structuring of intercomputer and network communications. The basic goal is to have different platforms speaking the same language. So my Unix server can talk to my Microsoft server and can talk to your Apple PC or Apple server without having any problems because they speak a common language, one that was built on a network architecture. The challenges that we're trying to overcome with this architecture were things like interoperability. Well, we can do that. It's a common language. We had to deal with availability, right? Ways to be able to find how to avoid what we call a single point of failure. So if some part of the network died, we could still get around. Flexibility, maintainability. These are all challenges we have in communications to try to not only have different platforms talk to each other, but to try to avoid any outages or loss of service between them. The architecture that most of us hear about is the OSI, the Open Systems Interconnect. The purpose of this architecture was to write a reference model that organizations could use for building intercomputer and network communications processes. It was really a proof of concept model that was made up of 7 layers. And we're going to talk about those layers, and I'm going to talk about how some of the technologies fall in those layers, so you can see that the OSI model didn't say you will use Ethernet. What it says is we have a data link layer, and this is its purpose, and here's how it interconnects with the network layer and the physical layer. So when we build our standards, we can build in this kind of a layered approach. And the idea is if I've got something new, I should be able to put it into that layer, and if I do it right and I put it into a layer, as long as it can talk to the layer above and the layer below, it's going to work. Example, IP version 6. If you haven't heard about it, look it up. That's the future. It's already here now. It's being implemented as I speak to you, and it's a drastic change in how IP addresses are assigned, but it just fits right in. Works with TCP, works with Ethernet, right? Different layers. So it was a perfect fit following this kind of open architecture.